This video is going to show you the second type of bonding that you guys need to know about, which is covalent bonding. In ionic bonding, the bonding was between a metal and a non-metal, where a metal gave up its electron to a non-metal. The problem with covalent bonding, which is between two non-metals, is that can't happen. If we have a look at chlorine, which reacts to form Cl2, both elements, both chlorine molecules, have 7 electrons in the outer shell, therefore they both want to gain one. So what happens, instead of donating or accepting electrons, they share to make them both think they have a full outer shell. So this is what happens. And you can see here, chlorine has got 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell, and this one has got 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell. So they both have full outer shells, giving it a formula of Cl2. So what is a covalent bond? A covalent bond is a shared pair of electrons. One electron from one atom, one electron from another. That's why throughout this you'll see me putting dots and crosses to show that one electron is from one atom, one is from the other. They need to keep reacting like this until they have a full outer shell. So for example, if I were to draw a chlorine atom, notice how I've only drawn the outer shell here. It needs to gain one electron to get a full outer shell. If I have a hydrogen atom, that also needs to gain one electron to get a full outer shell. Because they both want to gain and can't lose, they share. Now chlorine and hydrogen both have a full outer shell. There are 6 important examples that you'll need to know for the exam. Hydrogen, hydrochloric acid, hydrogen chloride, methane, oxygen, water and carbon dioxide. I'm going to show you how to draw these now. The first one is hydrogen. So hydrogen has 1 electron in the outer shell. So nice and simply, it needs to gain 1. It reacts with another hydrogen, and therefore it has a full outer shell. The second one, as I've already shown you, is hydrogen chloride, hydrochloric acid. Both have 1 electron that they need to gain, therefore there's 1 bond between them, it's just HCl. The next one is methane. Methane has 4 electrons in the outer shell, therefore it can make 4 bonds. So if you've got 4 hydrogen molecules around it, you have CH4. Notice how now carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell, and every hydrogen has got 2. So everything has a full outer shell. The next one is slightly different, which is oxygen. Now oxygen has 6 electrons in the outer shell. What it wants to do is gain 2 more. So if you were to react 2 molecules together, you need to share 2 electrons per atom. Notice how there are 2 X's from this oxygen atom and 2 dots from this oxygen atom. This is something called a double bond. And is drawn like that. If you were to just react hydrogen, which both only need 1 electron to get a full outer shell, with oxygen, then you add 1 on, and hydrogen now has a full outer shell. It means you then have to add another hydrogen to fill up the oxygen molecule. Now this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and each hydrogen has 2. Therefore it's completely full, and that's your water molecule. Carbon dioxide is the trickiest one that you'll come across in the exam. Every carbon atom has 4 electrons in the outer shell, which you should remember from last year. It's got 4 electrons in the outer shell, it needs to gain 4. Because it's only between 2 molecules, you know that each molecule is going to have a double bond, so 2 shared pairs of electrons. So redraw your carbon like this. Once you've done that, you need to put in your electrons from your oxygen atom as well, like that. Now we need 4 dots extra to complete the oxygen outer shell. So this oxygen now has 1, 2, 3, 4, 5, 6 of its original electrons plus 2 from carbon. And over here you do the same again. 1, 2, 3, 4, 5, 6 for the dots and 2 from the carbon. Each atom now has a full outer shell. These are also double bonds and can be drawn like that. Quick recap then. A covalent bond. It's a shared pair of electrons between 2 or more non-metals. One pair is a single bond, 2 pairs double bond, and 3 pairs is a triple bond. Another way to look at it is drawing almost like stickmen. Carbon is in group 4, so it needs to gain 4 electrons. It can make a maximum of 4 bonds. Nitrogen is in group 5, it needs to gain 3 electrons, so it can make 3 bonds. Oxygen is in group 6 and can make 2 bonds. Fluorine is in group 7, needs 1 electron and can make 1 bond. So if I wanted to react carbon and chlorine together, I know carbon can have 4 bonds. If I wanted to react it with chlorine, chlorine can only make 1, so I'll put 1 chlorine there, 1 chlorine there, 1 chlorine there, and 1 chlorine there. I would know that my formula is CCl4. If I wanted to react nitrogen and oxygen together, I'd start off with a nitrogen and I'd know that I can make 3 bonds. Put an oxygen in, that's 2 bonds taken up. I could put another oxygen in to take up that bond, then I'd have 1 spare, so add another nitrogen. There's your first bond, add another oxygen, and I have N2O3. That is harder than anything you will get in this exam. A final example, if I wanted to react 2 oxygens together, I know that oxygen can make 2 bonds, so I add in another oxygen molecule and I get a double bond. If I wanted nitrogen, which can make 3 bonds, I add another nitrogen and I get something like that, which is a triple bond.